My name is Simon. I'm a data scientist here at Algorithma. In today's day and age, AI is becoming more and more important. It's taking up more and more space in public discourse. More and more companies are using it. And that's why it's also increasingly important to understand how it works and what goes in behind the scenes, so to speak, to make these models function. And that's why we at Algorithma today published an article on our website describing how machine learning models are trained in a very high level. Machine learning models are sort of the core of AI, and training is where the magic happens, where we teach it to have the behavior we want it to have. If you're interested in knowing this sort of thing, I highly recommend you read the article. It gives a pretty good explanation and has some analogies to help you grasp the concept. But to give a very brief explanation, if that even is possible, machine learning models are basically, they're models. They're approximations of something. That something is some sort of phenomenon that we observe. We mathematically, we call that a function. So we say that machine learning models are function approximations. Now, we don't know the actual function or how it works. However, we can observe the data or the input and output. And that is what we use to train the model. We give the model a bunch of input data, and then we let it make outputs. And then we can compare the outputs of the model with the actual outputs of the phenomenon that we're trying to mimic. And we can calculate an error, or we call it a loss in machine learning. Now, all the machine learning model does is minimize the loss function. So we feed it a bunch of data, and we tweak the internal parameters so that the loss becomes as small as possible. With this comes some considerations, and mostly it has to do with data. It will get all its information from data, and that's why it's so important to give the model good data. Now, in the article, we talk about 3 major qualities of data. The first one is good quality, the second is high quantity, and the third one is balanced data. Good quality is basically as little noise, very clean data as possible, as well as that the data is relevant to the actual problem and that is consistent, basically. High quantity speaks for itself. We need a lot of data to actually be able to mimic the underlying behavior. If we have too little, there's going to be too many gaps that we don't know how the underlying function should behave. And thirdly, balanced data. It's very important that we feed it a wide variety of cases it may encounter in the real world. If we just feed it sort of low proportion of cases, it won't know what to do in the real world when it's fed a new case, which means it's going to tend to produce the output that it's already seen. And this can give us biased models, which is a big problem. In the article, we go into much more detailed explanation around these qualities, as well as considerations to make around the model itself to avoid things like overfitting and underfitting, which we explained there. So I highly recommend you go and read it, and I wish you all good luck with your machine learning and AI projects. Have a good one.